I'm frozen. Okay. On page 498, we're going to start with number 2, and we'll go back to number 1 on page 497. What made this page challenging? Or first, raise your hand if you didn't like this page. It was a little hard. Okay? What made it hard? What made it hard? Michaela?
The numbers, like, you couldn't really find.
Okay, it was possible to find answers, but did we have to? No, we didn't have to find answers. Audrey, what did you think made it hard?
The one where it says draw and label a trapezoid.
Hey, Rory, you're being really rude. Okay?
The one that says draw and label a trapezoid that has the same area but different measurements.
Okay, so you're talking about a specific problem that was hard.
Yeah.
Raise your hand if you kind of struggled with all of them. Okay, why? What made these problems harder than some of the other ones we did, Cam?
They mixed up the words.
Okay, they had lots of words. What do you mean by they mixed up the words?
They put in, like, different.
Okay, they put the words in different orders. Aubrey?
On the 2 on that, I thought that it was a little hard because I didn't know, because I didn't think that there was supposed to be, like, parentheses, but then I read and it wasn't.
Okay, so do we all agree that all of the words made it challenging? Okay, we said there were words that they put in a different order, they used different words. It was just that there were lots of words, and all of those words were important, and we had to read carefully. Okay, I'm not denying that these are not hard problems. I knew they were going to be hard for you before you even attempted them. And what did I tell you if you asked for help on these? Anybody ask me for help? Audrey? No? Anybody know what I told you if you asked for help yesterday? Kylie?
On this one, I just didn't know what I was, like, supposed to do. You just, told me, read it, kind of.
Okay, read it and just do something. I want you to process it. I want you to do whatever it is you think you're supposed to, even if when you're doing it, you're like, I don't think this is right. Because then when we go over it today, hopefully you're like, oh, that makes sense. I was processing it backwards, or I was thinking that word meant something else. But if you've spent time and struggled through it, you're learning, okay? Even if you don't get the right answer, you learned problem solving, struggling yesterday during this assignment. Okay, so number 2 says, Jeffrey purchased and downloaded 12 songs on Monday. He purchased 3 additional songs on Tuesday. The cost to download each song is $2. Write a numerical expression to represent this situation. Now, before you want to answer this, there's more than one correct answer, and I don't like the way they worded these 2 problems. Because typically, when it asks us to write an expression, it gives us a question to kind of guide us. And to explain that, like down here, it says which numerical expression represents the total cost of the trip. So they're saying, hey, you're trying to find a total cost. In the top 2, they don't give us what we're trying to find, which makes it even a little more challenging. Okay? What do you think our expression is going to find when we write it to this problem? Emma Irvin? The total cost of all of the songs. Okay, but in my opinion, they should have said, write an expression to find the total cost of the songs. There are more than one correct answer, so if the first one I write is not the one you have, don't change it yet. Who thinks they have one that works and can explain to me why they think it works? Waylon?
I put in parentheses 12 plus 3 times 2. I did that because it says that Jeffrey purchased 12 songs Monday and he purchased 3 songs on Tuesday.
Okay, so pause. So your 12 plus 3 represents the Monday songs plus the Tuesday songs. So in your parentheses, you found the total number of songs purchased, right? Okay, and then why did you multiply by 2?
Because it said each song was
because each song is $2. So Waylon's works. Did anybody have something different? There's another one. Everybody had that same thing? Okay, who can tell me the expression for total cost of Monday plus total cost of Tuesday? Total cost of Monday plus total cost of Tuesday. Madison?
12 times 2 in parentheses, and then plus 3 times 2.
I want everybody to write that one down also, because does that also work? Yeah, it's just a different way of thinking. Most of our brains probably work better with that one than the first one. Okay, but both of those would get us the same end result, the same total cost if we did our math correctly. Number 3, this is, 2 I felt like a lot of people could still get to. 3 is just kind of confusing unless we decide what are we trying to find. Can anybody answer that? Maura bought 3 bags of apples for her class. 1 full bag has 8 apples and each apple weighs 6 ounces. Write 2 different numerical expressions you could use to represent this situation. What am I finding, Emma? Because it doesn't give me a question.
You are finding how many, how much the apples?
So the total ounces of all the apples, yeah. So our expression that we're trying to write should give us a total number of ounces for all of the apples. Who thinks they have one that works and can explain it? Dylan?
3 times 8 in parentheses times 6.
Okay, explain that to me.
Because the 3 times 8 is how many apples there is. There's going to be 24 apples.
Okay, so 3 times 8 is the total number of apples because 3 bags, 8 apples in each, so that's total apples, okay?
And then times 6 because that each apple is 6 ounces.
And that's, so total apples times how much 1 apple weighs would give us total ounces. I agree. Rory, do you have a different way?
8 minus 3 times 6.
8 minus 3 would not work because you would do 8 apples minus 3 apples, which would be how many apples? 5 apples, and we have 24 apples. Waylon?
6 times 3 times 8.
That would give us the same answer, but we probably, because that would be 1, you would take 1 apple, the weight of 1 apple, and multiply it by bags. So that would be kind of a weird way to go about it. The answer, we would still get the same because it's all multiplication. So I think some of you just rearranged the numbers to get your second one, which is fine. I'm just trying to change our thought process. Audrey?
I did 8 plus 8 plus 8 in parentheses times 6.
Okay, and that would be that same thing. That would work. You're just trying to rewrite it because you're stuck. Cam, you have a different one?
I did 8 times 3 times 6.
Okay, which would be that same one, just rearranged. That's fine. Emma?
I did 8 times 6.
Okay, if we did 8 times 6 in parentheses, what is that telling me? What is 8 times 6 telling me?
8 times 8 times 8 times.
No, yeah, you're right. It is 8 plus 8 plus 8, 6 times. But in the context of this problem, Audrey?
You would be multiplying the ounces by each bag.
For 1 bag, that would tell you how many ounces are in 1 bag of apples. So here it was total apples times ounces. Here it's total ounces in 1 bag times the number of bags. Okay? This is what it wanted, but if you came up with this expression and then just wrote that expression different ways, that's fine. Okay? Like she wrote 6 or 8 plus 8 plus 8 times 6 would get us to the same result. Okay, does that kind of make sense? Now the trapezoid. 1. The trapezoid formula is kind of complex. Okay, when we do trapezoids next year, it's not hard math, it's just kind of a complex formula. That made this problem hard. But if we read carefully, it makes it easier. So Jane wants to find the area of a trapezoid. To find the area of a trapezoid, add the two bases. So first it tells us to add the two bases. Even if we don't know what bases of a trapezoid are, how can we figure it out, Rory?
You could,
How can I figure out which sides are the bases in my picture?
the top and bottom,
How do we know that? How can I know that?
because it says
Because it tells us, okay? We don't have to know which sides are the bases. It doesn't expect us to know that in 5th grade, but it expects us to be able to read. That's weird that they expect us to read big long words like base. Okay, so what's my first math problem going to be, Rory?
7 plus 3.
Okay, 7 plus 3. Oops, I almost made a parenthesis. So I added the two bases. Multiply by the height. Madison.
Multiply that by 3.
Times 3. Okay, and here's where I saw a lot of people miss a piece of it that's kind of important. You probably still would have got the same answer. Then, parentheses, I would do brackets just because I already have parentheses, but if you did another set of parentheses, that's fine. I'm going to add in brackets. There's my then.
Divide by 2.
Divide by 2. Yes.
I put what? 3 plus 7 plus 3 times 3 in a whole parenthesis. Would that be okay?
No, because if it's all in parentheses, what math would we have done first? 7 plus 3 times 3. Which one would we do first? We would do 3 times 3. That would give us a different answer. So we add the bases, then multiply by 3, then divide that answer by 2. I know, this is a weird one. That's why it's under the brain builders. It's trying to build up those brain muscles. Now, the second one was even harder. And some of you even struggled to understanding what it was even asking you to do. So it's asking us to draw and label. So we drew it. Label just means label important dimensions. That's a word I'm going to start using a lot towards the end of 5th grade and a ton in 6th grade. What is a dimension? Rory?
Like, the size of, like, it's like, like, when you do an area and it, like, 7 meters is, like, 1.
It's the important measurements in an object, okay? In geometry, which is math that deals with shapes, dimensions of different shapes are referred to as different things. So in a square, we usually call the two dimensions the length and the width. Those are the side lengths, sometimes is what they're called, but those are the dimensions, the important numbers that when I'm finding things out about rectangles, I need those numbers. In a trapezoid, there are 3 important dimensions. There are 2 bases and a height. I noticed some people when they were drawing them yesterday, and I just let you do it wrong so that I could have this conversation today. The height of a trapezoid is not this diagonal line. Okay, it's not ever a diagonal line. On any shape, the height will never be diagonal. It is always a straight up and down line. And the way that I teach students to remember that is when you go to the doctor. You guys have all been to the doctor, right? Mm-hmm. Okay, and they're measuring your height. That's a height. You guys all have measured heights before. If you would go up to the, because you actually get measured your height on a scale after they weigh you most of the time, correct? Mm-hmm. If you would walk up to the scale and lean on it when she's trying to do your height, or he, what would that nurse tell you to do, Caleb? Stand up straight. Raise your hand if you've ever had a nurse, even if you're trying to stand up straight. They say stand up straight every single time. Why? Michaela?
To see actually how tall you are.
To get an accurate height. If you are leaning, is your height accurate?
No.
What if you're raising your head up trying to be taller? No, you have to stand up straight. Anytime you are finding a height of any object, it is a straight up and down distance. Okay, that is a common error when we get here, so I start pushing it into your brain now. This distance from here to here will never be a height. Why not? Noel? It's a diagonal line. Okay, if you were a diagonal line with the wall when they're measuring your height, they would tell you to stand up straight, because a height has to be a straight up and down distance. Hey, Brody.
I got you.
So, second part. We're trying to draw, a trapezoid. I need 2 bases and a height. That when I did the math, it would give me the same answer as that one. So some of you found the answer to that to guide you, which is good, but you didn't even have to do that. I'm going to rewrite that same expression with just blanks in the spot where we had numbers. Why do I leave that back one as it divided by 2? Noel?
Because it will still stay the same as the
Because was that 2 a dimension of my trapezoid? No, it was just part of the formula or the math problem to find area of a trapezoid. Now, I'm going to keep this simple. I'm going to say my height is the same. How can just doing that help me? If I know this answer has to match this answer up here. Emma? So this one up here was 3 plus 7 in parentheses, but I can't use those same ones. But I need to get the same answer. Aubrey?
Because
It's delicious.
if you turn the trapezoid upside down, or if you turn it sideways, it'll still have the same height as what it is.
So she's saying I could rotate this. It would still be the same trapezoid though. We want a different trapezoid. Emma?
if you get the same height, then you could just use different numbers.
Yeah, I need a whole new trapezoid. But these 2 numbers added to what? 10. So these 2 numbers have to add to 10. Mila, what could they be?
5 and 2?
5 plus 2, 10, Mila.
8 plus 2?
8 plus 2 works. I could do a trapezoid that has 1 base of 2, 1 base of 8, and a height of 3. Would that look different than that one?
Yes.
What's another one? Kylie?
You could have, are we allowed to do a different height?
Yeah, let's wait on that. We'll get there. Brennan?
6 plus 4.
6 and 4 would work. Another one.
5 plus 5.
Nope, I was waiting for that one because that one's wrong. 5 plus 5 does not work. Who can tell me why? Callie.
Because the top line is looks smaller than 5 meters.
So, well, it doesn't matter how it looks. Doesn't matter how it looks. You're right. The way I have it drawn, it is less than 5 meters. Zach?
The top one is. The top one's smaller than the bottom one.
The bases have to be different. If both bases are 5 and the height is 3, what shape do we have, Noel?
Square.
Rectangle. We have a rectangle, so the only difference between a trapezoid and a rectangle is that the bases are different sizes. Okay, different sizes. So 1 and 9 was the only other one that would work there. There'd be a long, skinny rectangle or trapezoid. Okay, now that would have been the easiest way to find another one. There's 3 options there. But also, I'm going to come back up here since I erased it. What did all of this equal in here? Before we divide it by 2.
30.
If we can get all of this to equal 30, it will still be equivalent. So, Kylie, give me 2 numbers that multiply to get 30 that aren't 3 and 10. 5 and 6. I could put one of them here, 5. What would these 2 numbers have to add to be? 6. So it could be 4 and 2, 1 and 5. I could put a 6 here, and these 2 numbers would have to add to get 5. And I still would have the divide by 2 out there, okay? Raise your hand. Oh, darn it. Raise your hand if that one, like yesterday, you're like, no clue. And now you're like, huh, that kind of makes sense. Raise your hand if you still have no idea what it means. Okay, Caleb, what's confusing? So from the original one or from the second one? Okay, so did you have that one, this one correct up here? Okay, so what we did is we used what we know about expressions. It was 3 plus 7 times 3. All of that divided by 2 equals, I'm just going to put box. We had to come up with a new one where we changed those 3 important numbers, but our answer was still box, or the same thing. So we had to use what we know about expressions to kind of figure out, like, and again, try and leave some of them the same. If that's 3, Caleb, what's 3 plus 7? 10. So we came up with different combinations that equaled 10, because if this set of parentheses equals 10, then my end result would be the same as what it is up there. Does that make sense? Yeah. Okay, after we came up with those combinations, we went a little bit further and said all of this in parentheses has to equal 30. So we thought of different things that multiply together to get 30, and we said this times that second number would have to equal 30, and then went back to figure out what adds. That's the more complex and harder way to do it. Kylie.
So in my brackets, I didn't have something that equals 30. Because for my first one, I had 3 plus 7 times 3, and then I did divided by 2.
Mm-hmm.
And for my second one, I did 2 plus 6 times
2
3.
plus 6 would be 12 times 3 would be 36 divided by 2 is 18.
2 plus 6. 8 times 4.
8 times 4 is 32. So that would have given you an area of 16 instead of 15. Does that make sense?
Yeah.
Okay. Moving on. Vocabulary word. And again, that was a brain builder. It was to build your brain muscles. Drake. What a blank expression, what's going on here? A blank expression like the quantity 3 times 5 plus the quantity 4 minus 1 is a combination of numbers and at least one operation. Numerical, yeah. Numerical. It's a hard word. Okay, last one. Denzel and 3 friends go to the movies. So how many people are going to the movies?
4.
4 people are going to the movies. At the movies, what are they buying, Cam? A ticket, a snack, and a drink. All 4 of them are buying a ticket, a snack, and a drink. Tyson, which of these expressions can help me find the total cost? B, because this is the total for one person. 8 plus 4, that's the total cost for one person, and then they did times 4 because there's 4 of them. Flip backwards to page 497. I can't flip backwards because it'll kick me out of my book up there. Number 1. What was the subtraction expression that was in both of them, Mila? I can see it. 8 minus 3. In expression 2, the difference is multiplied by what, Audrey? 4. So Noelle, so expression 2 is blank times larger. 4 times larger. Okay, I want you to locate the note card that I told you to just use as a bookmark yesterday. We're going to add to it. If you weren't here yesterday, just hop up and go grab a note card. We are going to do some more examples because do you agree these were a little challenging? Okay, and we're going to go back to statements. These are actual word problems. I'm going to take us back to just phrases. My board unfreezes. Okay, this says write an expression for the sequence of operations described below. Sounds fancy. All it is it's asking you to translate this phrase into a numerical expression. So do this on your note card. Multiply 3 by 2, then add 8 to the result. This is the first one where it's asked us to do something with the result. What does that mean, the result? Cam?
Add 8 to the answer.
Yeah, when it says result, it's talking about after you do this, do that to this answer. Okay, so everybody on your note card, try and write down an expression for that phrase. And I will point out, anytime you're entering these on an online program, pay attention to the words that tell you how to enter it because each one's slightly different. This one is saying use just the X if you want to use a multiplication sign, and we're using the slash as a division sign when we enter it. Okay, Rory, what'd you come up with for this one?
3 times 2 in parentheses.
Okay, 3 times 2 in parentheses. And when you're typing this on a Chromebook, it's a little bit different, but so 3 times 2 in parentheses, okay? Plus 8, because it says add 8 to the result. So that is I have to find that, and then I'm going to add 8 to that answer. Three increased by the sum of 5 and 6. Write down your expression. 3 increased by the sum of 5 and 6. Waylon, what'd you come up with?
3 plus in parentheses 5 plus 6.
Good job. 3 plus parentheses 5 plus 6. What told us that we had to put parentheses around that 5 and 6, Waylon?
3 increased by the sum of 5 and
the word sum told us, hey, you have to find this answer because it's 3 increased by the answer to an addition problem. Ooh, challenge zone. Isn't this fast or not? 3 plus the sum of 8 and 4. 3 plus the sum of 8 and 4. You writing these down?
Yeah, but for the last one, could you have done 5 plus 6 in parentheses, 9 plus 3?
Probably, but online, I would always suggest put it in the order it lists it. These are ones where, like Rory asked if you flip the 6 and the 5. On here, it might mark it wrong. But usually if I give you these online, I would go back and check and see what they marked wrong and see if I disagree. Like in my class earlier, it said double 6. So they wanted 6 times 2. Do we all agree that 6 times 2 is doubling 6? But someone said 6 plus 6. Is that still doubling 6? Yeah, so I typed it in because I didn't think it would accept it, but I was curious too, and it marked it wrong. And I said that was one where I would have gone back in and said, yep, you get credit for that one. What do you think, Drake?
3 plus parentheses, 8 plus 4 parentheses.
Good job. Trying to get to a hard one. Subtract the product of 3 and 2 from 6. This one's tricky. Subtract the product of 3 and 2 from 6. I want everybody to write something down. Subtract the product of 3 and 2 from 6. Emma, what'd you come up with?
I put parentheses 3 times 2,
Oops.
parentheses minus 6.
So parentheses 3 minus 2. 3 times 2 minus 6. Cam?
6 minus 3 plus 2.
3 times 2.
No, 3 plus 2.
It should be times because product is what?
Answer
Answer to a multiplication sentence. So these are probably the 2 that people came up with. Are they the same? They are not the same. In this case, the answers are the same, but those are not the same expressions. So let's look here. Subtract the product from 6. So this is saying take the product away from 6. So that is this one. I'm taking away the product from 6. So this one is 6 minus the quantity 3 times 2. Again, the answers would be the same in this case.
6 minus 2 in parentheses, minus 3.
6 minus 2. No, because it's saying subtract the product, which means the answer to a multiplication problem. So the multiplication problem is 3 times 2. This one's hard. That's why I said this one's tricky. That's why I wrote it in red before we typed it so we could discuss it. So 6 minus 3 times 2, close parentheses. 3 fewer than the difference of 8 and 5. Again, anytime there's subtraction or division involved, it gets kind of fuzzy. You got to read carefully to decide if it's this minus that or that minus this. 3 fewer than the difference of 8 and 5. Caleb. What does difference mean? Okay, so let's start with difference of 8 and 5. Now we have to decide about the 3 fewer than. Is it 3 minus that or that minus 3? Arabella?
That minus 3.
Why?
Because it says 3 fewer from.
So 3 fewer than that. 3 fewer than that. If I said I have 3 fewer dollars than Easton, almost said Eli, would you take his minus $3 or $3 minus his money? You would take his minus $3. So this would be 3 fewer than that amount. Are these tricky? Yeah, they require us to process them. They're not quick and easy. The words aren't always in, or the numbers aren't always in the right order in the words as they are in the expression. Okay? Tomorrow, in class, you're working on it. You're doing an in-class assignment. Have a seat. I dismiss you when it's time to go. I promise I'll let you go. Tomorrow, you're doing an in-class assignment. It will have some of these on it. It'll have order of operation problems on it. It'll have the other kind of writing expressions where I give you 4 plus 4 plus 4, and you tell me that's the same as 3 times 4. Okay, like we did Monday, Tuesday. Okay, so your only homework tonight is get your weekly worksheets done. If your weekly worksheet is already turned in, then you don't have any homework tonight. Okay, see you guys tomorrow. Just leave it as a bookmark.